So thank you everyone for coming to my talk. My name is David Karamgard, that is an actual name, and I'm a developer advocate for Stream Native. So we're the company behind Apache Pulsar. And today I want to give a little talk, a kind of a light introduction to how you would enable real-time analytics using the combination of just Apache Pulsar and Apache Pinot. So we're gonna have a little bit of fun, and let's say you're part of a development team and your company wants to get everybody immersed in real-time analytics. So this is coming in fresh new, you're on this team, and they say, okay, we're gonna have a 3-day hackathon to help everybody learn about real-time analytics. So at first everybody's really excited, hey, this is great. This is a cool project, it's something I haven't done before, we're looking to learn about these things. Let's all get on board and do it. And so since everybody's building essentially the same thing, there's gonna be a little bit of a different criteria around it, right? So your goal for this 3-day exercise is to develop a real-time analytics platform from scratch, right? You're gonna build something out, give a little proof of concept, and you're gonna demo it to everybody. So some of the criteria for evaluating this, and what the judges are gonna look at in this hypothetical hackathon, are the following things. So first and foremost is they want you to be able to integrate with a live data source. Synthetic data is not really interesting. Synthetic data or artificial random data isn't really gonna demonstrate the value of a real-time analytics platform. So one of the key features is, can you consume real data for this? That's one of the key criteria for that. Secondly, they want you to focus on resource efficiency. So the demo should be able to run on a laptop. Part of it being, efficiency is something that affects cost later on, and so being able to do more with less at a micro scale helps contain your costs as you scale out the solution, whatever that solution may be. So if you can do more with less in the prototype, it's gonna reap benefits later on when you move this thing into production, theoretically. I've got the out of order. Next, part of the criteria is gonna be to support visualization. So the judges are gonna be data analysts, people who are gonna be able to, they don't wanna look at your code, they don't wanna run a bunch of queries, they wanna have dashboards. So as long as you can feed dashboards, that's gonna be one of the criteria to do it, so you have to have that integrated to your platform on day one. In order to have some simple analytics, they wanted to be able to support just simple windowing analytics at first, and then you can build on later on. So just to prove that you can do analytics, but not necessarily go all in on that. And then obviously I got these out of order. Playing with my slides last minute. Obviously focus on low latency, right? This is a real-time analytics platform, so it's kind of implied in the statement, but low latency is key. You'll be evaluated on how quickly the data comes in before it's generated at the source and before you can actually do analytics on it, right? That's key for this particular use case, as you'll see. So everybody's like, okay, then they get this blank look on their face. Reality sets in, okay. Anybody know how to build a real-time analytics platform? Have anybody done this before? Nope, I don't know anything about it. Not a clue. How do you get started with this thing, right? What are we gonna do? So maybe you go and say, oh, ask ChatGPT, right? That's kind of what we do. We go, write me a real-time analytics platform. But that's not really gonna help you learn things, and that's not really interesting to talk about. So, so they go and do some research, and they come up with a perfect, this developer takes the initiative and he says, hey, I found the perfect resource, right? So apologies in advance. Everybody here, if you're not aware of this, StarTree is offering this free book, download for free. If you scan that query code, it'll take you to their info wall, and you can enter your information to get the entire book for free. I've done it, I love it. Mark Needham's book is great. I reached out to him, asked for permission. I haven't been able to contact with him, so apologies in advance for using it. But that's how you do it, right? You're a developer, you find the resource that tells you, okay, let's build a real-time analytics platform. And you can get it for free. Now they open up the book and you come to about chapter 2, halfway in there, and then you come to this sort of reference architecture diagram, for lack of a better term, that separates what a real-time analytics stack is made of, what all the different parts are, right? And so separation of boundaries and concerns and what they integrate. So you have these different parts, and you as the team with 3 days to build something, this makes sense. You got producers, you've got a streaming platform, you got a stream processing platform, a serving layer, and then potentially a front end. That's really it, and it makes perfect sense. And all you have to do is just, pick out your actual components, your implementation technologies, and put these together in a way, and then you can start solutioning on top of that. So they drill into the book, they open up the page, and they say, okay, streaming data platform. The book doesn't flash for you like this, but I want to highlight attention to it is the most important part of the decision. But if you read the book, and it's a good advice, it's a great place to get started. Again, it tells you streaming platform is key. That is the heart and soul of the entire platform, and from that decision, all your other technical resources and abilities to do things will be controlled by that. So the key criteria to a streaming data platform is it has to provide topics. Topics are individual components of data. We're all aware of the concept of topics, but that's what essentially are table stakes for a streaming data platform. As long as you support topics with schemas, segregate the data, I can consume from the data later, you have a streaming data platform. The book also goes on to give a fair assessment of the state of affairs of where we are. Kafka and Kinesis are kind of initial front runners, but there are new contenders in the space, and it's growing every day, and there's other presenters from other conferences at the conference today that have other solutions as well. So you look at these, and so you come to the team comes to the crossroads where you have to start deciding, okay, what am I going to pick from all these different menu items? Obvious fair concerns come up. Well, we don't want to really get into cloud vendor lock-in, for example. Maybe your company is cloud agnostic, so you don't want to pick something like Amazon Kinesis or Google PubSub because that sort of locks you into an individual vendor. Maybe another concern that you have is budget, budgetary. If it's a licensed software or a SaaS solution that's more costly, maybe you're not going to be able to get that approved, and your company's very cost sensitive to this, so you're not really going to spend that money. So that kind of starts chewing down your list a little bit. And then obviously for the top, because my company does Apache Pulsar, everybody picks Apache Pulsar, right? Sounds cool. Let's try it out. It's there and it's 100% free. Next, you have to look at the next part of that component you're going to choose is sort of the event producers. And in the book, he breaks it down into 3 different categories. Overall, the first one being, existing data sources. So you have a lot of this data sitting in databases throughout your organization. A very, very common pattern is use something like, Debezium to connect to it, change data capture, bring it right into your system. Now you have it, right? That's one of those platforms. Another one is the, event trackers, for example. That's, embed little information inside web pages. You can track in real time who's interacting with your website, sort of thing. And then sort of the third category is a catch-all of, every one of these streaming platforms has an SDK. We can use something like that. So for real-time analytics, because your goal is to have low latency, you really do want to, the first one won't work because you're taking a data source, stuffing it into a database, which takes time, and then you're using Debezium to do the CDC, which takes time, and then you're putting it into your streaming platform. So you're introducing a lot of latency that you don't necessarily need to have. The second one, event trackers, doesn't really make sense for this particular use case, the data set that they pick, and so they're kind of just say, okay, we're going to use, just SDKs is what's left. That's kind of, by default, we're just going to do that, which is fine. We'll telegraph it a little bit. They use Pulsar IO connectors as a framework that allows you to use SDKs very easily to get data into the system, and then they'll decide to use that. Next is the serving layer. The book lays out a couple different options that are obviously prominent there. Pinot, since everybody's here knows Pinot. There's other competitors in the space. They all just perform the same thing. They are the serving layer for real-time dashboards, data applications, queries, everything else. It is where the data lives. It's where it's finally processed and stored, and you want to get the data and do analytics from it. That's your serving layer. Not too much of a mystery here. They already have Pinot experts, so maybe they went to the summit, and now they're experts in Pinot, and so they're like, great, we'll just pick Pinot as our serving layer, no problem. Next is the front end. So again, if you have the front end in place, and the book breaks down different types of consumers and front ends that you might have, since this particular hackathon requires you to have dashboards, you're into the data visualization space, and the book clearly recommends, hey, Superset is one of those that's recommended, so great. We'll just go ahead and pick one of those things. That's not a problem with that. It works well. And making it even easier, we know it integrates because there's already a Docker image for this, so we can run it on a laptop. That's great, so we know we don't have to worry about that too much. And that's great, so it keeps your technological stack from growing too much, and you have all this information there, so you don't have to have a lot of yet another system just to do dashboards. So now the hardest part, the stream processing logic, right? This is all stream processing layers basically perform this function at a very high level. Events come in from a raw source, they sit in this input topic, and then you take the information from that input topic and you do transformations, you do analytics, you perform a function on that data, and the resulting output you put to an output topic, which then eventually feeds the serving layer, right? So this is where you do your ETL, you're doing data transformations, you're doing windowing, bucketing, all these different things, maybe joining data from different streams, all this sort of thing. That constitutes what stream processing is. Now, when you're choosing a stream processing framework, let's see if this works. The book breaks it down into, thinks of it in terms of categories, right? So you have there's different types of stream processing, and based on your needs, you should pick the right one. So there's different categories like streaming analytics, where you're doing stateful aggregations, windowing operations. There's event-driven ones, so event by event processing, for example, you want to do lookups or something like that. And then there's obviously the streaming ETL sort of things, where you're doing a little more complex things, maybe like joining different streams, integrating data, repartitioning of data, structuring around, moving it, sort of things, right? So you really should pick it based on what you need. Don't start with a platform to pick it. I'm going to show you how you can do different things here. So based on the hackathon thing, they've really said, this is what we need. We need windowing operations, and the data's coming in, we're going to have to do some sort of transformation. It's never going to come in perfectly how we want it for the serving layer, so let's anticipate there's going to be some transformations that need to be done. Yep, flashing it there. All right, cool. Hey, somebody pops in, says, hey, I got an idea. I'm good at both of these things, right? That's great. We know this person, or this particular project we're referring to, and it's fair, right? He has a point that these things that all things are available for that. So based on what you've evaluated, the team comes to decide, okay, you have a point. The Squirrel's great for that, or it could be Spark or whatever, or Beam or whatever sort of distributed processing tooling that you want to do, and he has a point, right? But you really don't want to put up another system. We're really trying to be efficient, right? And so first, let's see if we can do what we can do with other platforms, right? And the other issue is, if you want to do some of these programming things, it's a very complex API. I need to know a low-level API. If I'm using like Spark, for example, I got to understand data frames and all these different things. Maybe I got to learn a different language. Somebody's pushing back like, there's a lot coming at me already. I don't know, this is maybe too much. So the suggestion is, and I'm going to mention here, is Pulsar Functions is something that does a lot of these capabilities and that you can use. It comes for free with the Pulsar framework, so you can get a lot of these capabilities without having to get another platform involved, right? You can do that for now, but you can always bring in something later. It's not an either-or proposition, it's both. So it's pick the right tool for the job. So just because you're using Pulsar Functions doesn't mean you can't use Flink later or Spark later. It means use the right tool for the job, and we'll get into what we can do with this particular use case. So what are Pulsar Functions? Well, I've also found a book. She did her research, not to be one-up. She found another book, which is also available for free download. If you scan that QWERTY code, you can get the entire book. I was able to contact the author, and he gave me permission to do it because I'm the author. So you're allowed to have the book. And allowed to use these permissions, right? So again, you go doing a little bit of exploring on that. Yeah, you can download it for free as well. That's great. So what is it? Open up the book, get to about chapter 4. And Pulsar Functions is basically a lightweight computing framework, an event-driven processing framework. An event comes in, an event comes out. It has all the benefits of your serverless computing, but you're not bound to AWS, something like AWS Lambdas or Google Functions or something like that. So it has the same concept, same very simple programming model, but it's tied to Apache Pulsar. And so again, you can very easily, as it says here, you can ingest data from different topics. You can be configured to consume data from any different topic you want. When a message comes in, your application logic gets applied to it, and then you can either optionally, if you return a value, it publishes it to an output topic if you want to do the input-output processing, or you can also do something like insert to a database and not return a value. So it's really up to you what you want to do. It's a very simple framework, and you can use all these different languages: Java, Python, Go, Golang, Node.js, whatever you want to write the languages you want. Right, so it's, no more frameworks. It's already built in. It kind of came for free. So let's look at this first. Is what you're basically saying. And it's cloud provider agnostic. You can run it anywhere. You don't need AWS Lambdas. You don't need anything like that. So if you go to the Java, the official Pulsar documentation, you'll find this page here that basically shows the API for all the different languages. I highlighted Java, but the same documentations for Python and Go, and just showing you this is the API. This is it. If you can write a piece of code that executes a single method, you can write a Pulsar function. So it's very, very low barrier for entry. You don't have to know a complex SDK. You don't have to understand data frames. You could give this to an intern that comes in for summer and can write whatever they want, and you can do all the different coding that you want there. It's very easy to do. Obviously it's typed, so your schema type is the input type on the left. You get that raw value. You optionally return a value. That's your output type, and that's it. You process it whatever you want. And because it's a coding language and you can pack it with whatever you want, you can literally put any third-party dependency in there that you want and do whatever you want. So if you want to have a machine learning model execute in there and take the data and return a value, you can do that. If you want to have a lookup in a real-time in-memory cache, return the value, you can do that. Whatever you want, you can do because it's code. And most importantly, it's a very, very simple and clean API. Nothing very complex about it. Additionally, if you go in the documentation, you can configure it. Pulsar functions are very configurable, and they have all these different values in there. So you can specify windowing. And the key takeaway is you can do size windows by account. You can do sizing windows by a duration. So keep this open for 5 seconds. Keep it open for the last 50 events, whatever you want. Or you can have a sliding window, right? So you don't break it up into 50 bytes or 50 messages, 50 messages, 50 messages. You do a sliding rolling window. And those are both available, and you just specify it when you configure it. So windowing is provided. So Pulsar Functions Framework will gather all the functions of a small window for you and allow you to do the processing and all the events at once. So it's great. So now going back to this, choosing the stream processing framework based on the hackathon requirements, Pulsar Functions cover event-by-event processing. They give you that. They give you windowing operations, because we just talked about that. And they give you the ability to do filtering, routing, transformations, because it's code and an event comes in, you can change it however you want in the code. So there's no real issue with that. Somebody's not very happy about that decision, but that's okay. So summarizing the discussion that they had, right? So this is the real-time analytics stack, going back to putting all the pieces together. They're going to use Pulsar for the streaming platform. We're going to use Pinot for the serving layer, Superset for the front end, and for the stream processing for now, and the event producers both will be Pulsar functions. So that's it. So they have a very simple stack, very easy to deploy, and they're all ready to go. So now that they've picked the technologies that drives their decisions, let's get into the planning and coding phase, and then I'll show you some code. We can wrap this up here. So I promised code. If you scan the QR code on the left, that's the entire project that runs the entire framework that I'm going to demo here today. Starts the whole infrastructure, starts the Pulsar functions, the I/O connection, and you can run the demo yourself. We'll demo it live. On the right is the source code for some of the Java functions. I put them in a separate repo so you can look at the code later, and I'll briefly cover those if time's permitting. Both of those. Everybody who want those got those. Okay. So here's the key. The requirement number 1 was a live, true data source. So I know in the talk, I think I said I was going to talk about IoT data, but I found that was very boring and random, and it wasn't a very interesting data set. So I took it upon myself to pivot and use the Coinbase WebSocket API instead. So if you scan that query code, it'll take you to the documentation for the entire WebSocket. But basically, to receive data, what you do is send a message that says, I'm interested in these channels. This is the data I want coming in. And you can also filter it by, these are the product pairs. This is the crypto pairs I'm interested in. So I want Ethereum, I want some Bitcoin to US dollars, I want Dogecoin, whatever. And you submit that WebSocket out, and then it just sends the data to you automatically, right? So the WebSocket data coming back looks something like this. This is for the ticker channel. So you get some interesting data, product IDs, prices, last 24-hour windowing data, things like that. A timestamp, which is very important for analytics. Pinot loves timestamps, and we need timestamps for this. Trade sizes, et cetera. So this is the schema's already defined for you. This is the types of messages you're going to get if you subscribe to that channel. We're also going to subscribe to the auction message. So you're trying to do some pairing of data, and it can come in for analytics later, like what's the best bid, what's the best ask, what's the sizes, et cetera. So you're trying to do some market making there. That's also available. It also has the product ID. It also has the timestamp, so you can correlate it later on. So it's very, very, very good data set. And last but not least is a request for quote coming in. So you're trying to match people up after you've done an auction. You're trying to match them back together. Sizing and is it the seller side, is it the buyer side, what's the price as well. So all this information comes in and we get it for free. So phase 1, they're going to break it down to 2 phases. So phase 1 is they're just going to get it end-to-end, live data and dashboards. That's our goals for this phase 1, and let's talk about the plan of how we're going to do this. So they'll install Pulsar, and within the Pulsar ecosystem, first thing they're going to do is create a Pulsar I/O function that connects to the WebSocket, there's a Coinbase WebSocket API sitting out there somewhere, and this Pulsar IO is just gonna reach out over the WebSocket, send the subscription message, and start getting the data. Messages are gonna start coming back in, and it's gonna publish that information to a Coinbase live feed topic. We'll just put the data in there, all the data is coming in. Now it's worth noting that all this data, since we did from multiple channels, data from all different types are gonna be mixed into this, right? So the next thing we're gonna have to do is have a Pulsar function that does content-based routing, right? So we have messages, it's gonna pull messages off of that topic, and if the key is equal to auction, then we're gonna tie a schema to it or write it to its own topic. If the key is equal to, if it's a ticker message, so we'll go ahead and put that to a ticker topic. And if it's the request for quote, we can go ahead and do content-based routing on that and write it to its own topic. So that's bringing in the data. We've brought the data in, we've sorted it out, we've done some routing on that. Next, stand up Apache Pinot. And with Apache Pinot, we'll go ahead and first use the Pinot plugin for Pulsar. There's one that comes out of the box. We'll configure that, make sure it's configured. And then we'll create an auction table, define an auction table that maps to the Coinbase auction topic, a ticker symbol, or ticker table rather, and an RFQ table that all maps to the corresponding data. And then we'll use the Pinot connector to connect to each one of those. One by one, they'll each be configured to use that. And it'll consume the data directly. Come on, it's supposed to work here. Oh, sorry. And then it'll consume the data off of Pulsar directly, so there's no, we just configure it. And then we'll install the superset plugin within the Pinot space, create a few dashboards, and then be able to feed it from there. So that's step one. When we look at the code, that's the plan of what we're doing. That's the general plan. Once that's working, the next step was to do the windowing analytics, right? So now you've met the rest of the requirements. So you already have the Coinbase ticker. We sorted it upstream. So now we're starting with the fact that we've had the Coinbase ticker. We've sorted this data out and highlighting again that Pulsar functions provide windowing support. So we'll just create a different Pulsar function that consumes off of that ticker information and does some windowing analytics on it and spits it out to a separate topic, Coinbase topic stats. It has the same product ID, the same sequence ID, so you can correlate these information back in real time and do a query on that and have all the information available to you. And since we can write them in Python, and NumPy is a really cool library for that, then we can use that to do some interesting stats around exponential weighted moving average or variances and means, information that might be useful for machine learning models. And then the second version of this talk where I go into that, you can do a machine learning model and just read the data right out of there as well. And then the Pinot, just to prove that it's there, we'll also use the Pinot plugin and have a ticker stats table available so we can actually query the data and see what it's there. This code is available. I'll just highlight that how we do the windowing function here is we keep these values in memory. We sort them by the product ID, and then we use the pandas libraries to compute the most recent metric. And then we also have rolling library. We have a rolling version as well, so you can compute all these different values. The immediate one, and then you can do one over a 10 event window, 20 event window, whatever you want. It's whatever code you want to use there. So all your different libraries that you know and love in Python, you can bring in as well to Pulsar functions and do some really cool analytical stuff. So with that, I will stop and I'll do the rest is going to be code-based and starting the demo and walking you through the code. Hopefully that'll be interesting on that. So we'll go ahead and escape out of this. And the first thing I'm going to do, I'm in the repo, in the repository where I have the code, and I have my little super cheat code where I'm just going to start everything, and it's going to start everything running in the background. I'm going to go ahead and let that run. See if in here's the corresponding repo. We'll come back and see if everything ran well. But this is, if you go to that query code on the left that you scanned had the code, this is exactly the code that you will see. So we'll go ahead and get started. The bin starts everything. There's a very, I think, detailed README here that walking it through step by step, starting Pulsar, starting the IO connector, ingesting the data. You can validate the data by querying Pulsar directly to say, give me the information from this topic. And you can peek in and see that information. Talks a little bit about how you start the content-based router. My start script is doing all this for us behind the scenes, so I don't want to have to do this one by one. It's boring to show that here. Next, you can do you'll start the building of the ticker stats. Because it's a Python one, you can make the code here in real time, and the code I'll show you in a minute is within this project. So if you do some changes, you can change it real time and deploy it, have a new version out there. The script goes ahead and starts that, and then you can see different data starts coming in. So you see things like I'm computing, these values now, and they're corresponding to the product ID. So it's not the raw data. I've already started doing analytics on it using just a simple function, one class. Next section goes through about we're starting Apache Pinot. Get that up and running. You can validate everything that's running inside of there. We'll get into a little bit about, there's only a few changes you have to make to that to get it to use Pulsar as your data source. Creating some table definitions. Obviously, I have some schemas defined, and we'll explore those in the UI when we get there. But basically, you have to create the tables the first time, specify the schema, specify the table definition. And then last but not least, start up a superset, and I've saved some dashboards for you. You import them, and you should be able to see some interesting data. So that's what this does, and if you want to follow it at your leisure, this sort of walks you through it step by step. Going into the infrastructure part first, just to show there's no sleight of hand. This is just regular Apache Pulsar, latest version, got all your components you need. Zookeeper for a little bit longer. Oxio will soon be coming and solve all your Zookeeper problems. Bookies and brokers and everything there. You mount the functions data there. That's the key because we have the artifacts for the functions are here. So the Pulsar IO connector is Java. We build it and bundle it into this NAR file. When we go to deploy it, we use a config file and the NAR file. And just to give you an idea, so this is exactly how you configure it. You can specify where I'm going to publish the data to. This is the subscription I showed you earlier. So you can change this. I want to listen to more coins. I want less. I want new channels. I want less channels. This is it. You can specify processing semantics, guarantees, all this different thing there. Content-based router, similar thing. It's a simple Java code. We have the NAR file. I can show you the Java code for this. Key takeaway here is that we're consuming from this live feed, and then you can use the user configuration, right? So we can dynamically specify for the types that are coming in where we're going to route it to, right? So this is just very easy to config. You can pass in whatever you want later on. So if you want to add a third type, it's just a matter of adding a value to this one and changing some code, and it'll just work. So it's very easy to plug that in. We won't worry about that one now. And then last but not least, just to go into the windowing function that's here. It's a Python one just to give you a variety. Not everybody writes in Java. So this is how you enable schemas and functions inside Pulsar. So I define the schema itself, the value coming in so we know what the information is, and what's coming out, right? So the sequence and product ID are what we're putting out, along with their calculated stats and a timestamp on those. And here's the logic of how we do it. Again, as I mentioned before, we can walk through the code down here. So this is again the single method you have to implement, process. The input comes in, you look at the product ID, you put it in a bucket of all the previous product IDs, so you sort them out. You keep those you keep a rolling window of however many you need, 20, 30, 40, whatever. Then you just call the method that says, calculate the latest metrics for that, and you spit them back out. So all these metrics, again, like I said, just use, you just go for that product ID, give me the last 20 things as a list, put it into pandas, say calculate it, boom. All that magic that pandas does is there available for you very easily on that. For the Pinot, just covering what you have to do here differently, it's basically the same way of starting it with the difference of you have to add this one here to make sure it can talk to Pulsar. So that's all that's required there. This is basically, I think I copied and pasted this from their example on the website of how to get started in Docker. This is it, with that one exception as well. It has the server superset. I'm enabling superset. Again, it comes from Apache Pinot. We're just going to enable it, have it work. Mount a few different things that have the schemas defined. We'll look at the schemas here, but just to show there's a JSON file when you first create it that's being created for that. And that's really it. Get out of this guy here for a minute. Just to complete the loop on this, here's the Java code for here we go, the live feed. Sorry about that. It's very simple. It is a single method. It's a source. So when we first open it, we just create a WebSocket. We pass in that subscription property. We grab it from the configuration and send it into the WebSocket API. We create a client wrapper, which every time a message comes in, it just takes that information. It's a raw string. parses out the type field, so it puts it in the key, so we know how to sort it for the content-based router, publish it out, and that's it. So that's all it is. It just, once it starts, it just sits there and listens to all the data and consuming it there, and then just quickly to cover all the bases. Content-based router is also very easy, and it does some transformation as well. So the data comes in, now we're getting all this different data. We grab that key field that we just encoded with, and then we use that to determine we create a new message, which output topic we're going to. I can publish it to A, B, or C based on what the value is. And I take that JSON and then I serialize it into something that matches that schema, right? But as part of that process, what I've noticed was, at least one of the issues I came up with was the data coming in from this Coinbase feed has microsecond accuracy. Pinot does not like that right now. I tried everything I could in my power to make it handle microseconds. It couldn't do it. So I added a quick translation that will basically round it up to the next millisecond and return the milliseconds instead. So this way I have a time field. So this is a simple transformation that was necessary for it to be consumable by Pinot. So that's really it. It's very, very simple code. Nothing very, very fancy here. Now, if everything went well and there's not a ton of errors or anything like that, hopefully when we go here, we're going to see, let's see if the demo gods are smiling on me today. Yes. That's it. We have Pinot running locally. We have the 4 tables. They're all defined, so let's look at like more interesting ones. So the ticker one, it's defined as a real-time one. The schema types are here on the left. It matches exactly what we saw from the WebSocket API. Nothing, no mystery there. Here's sort of how you configure it differently. This is how you integrate with Pulsar directly. Specify the topic, you tell it's Pulsar, and it knows to use that Pulsar Pinot plugin that you've started with, and that's it. Now all this data that we just published in the topic is available for consumption in this table. And just to prove it, let's go to the query. Come on now. That's gonna make me a liar. Of course it is. That's gonna make the demo very, very boring. What's going on with this? Is there no data there or what? It's really a bummer. This worked an hour ago. There's live data there. Maybe. I hope not. Maybe they realize I've been hammering it, practicing this demo, and they're like, we're shutting this guy down. I don't know. It's crazy. There's nothing in the air. I could try restarting it, so. Let's see what's going on there. Sorry about that. I'll try real quick. See if I'm getting any data at all. Nope. This is great. It's gonna totally ruin my cold demo. That's all right. So no data's coming in. That's all right. We can pivot on the fly here. I'm going to go to the dashboard. So now you get to learn how to debug Pulsar functions, which was not part of the original plan. Oops, sorry. Didn't want to go there. I can try restart. I'm going to go. This light is right in my face. I can't see. One more time. Let me do this instead. Maybe if we just restart it. So I'm going to stop everything and try and restart it really quick to see if that triggers whatever's going on with Coinbase. Everything, it's just weird. So there's no data coming in. I apologize. We still have 10 minutes to get this up and running. Give it one more second. So we'll watch it here in real time. Start it back up. See if it works. It's just weird. The data's there. It's configured properly. There's just no data in that. the meantime, see what the error is. Hopefully it's just a technical issue with the API for some reason. Here we go, starting the data feed. We'll know pretty quick if there's an issue or not. Okay, I'm gonna go look. So we're just going to go right into the logs and see what the heck's going on. Hopefully, if it's some sort of credentials thing, why can't I CD into that? There's something going on. Love technology. Well, let's see here. That does not look promising. That's fine. So it's creating, you can see it created the class, it passed the information through. Network at me. And he asked if I wanted a live one. So I can't connect out over the internet. The Wi-Fi went down. Let's see if I can use this one. There we go. So that was the issue. Let's try it one more time. Gotta love network Wi-Fi. Gotta love the Wi-Fi at the hotel. All right, one more time. So while we're waiting for this to start up, since we're going to be short on time, any questions now? We can start the Q&A now, and then we can get back to the demo if there's any questions to be efficient, other than why your demo doesn't work, because it's the network.
Thanks for the nice presentation. So I know nothing about Pulsar. I was wondering, where do the functions run, especially if they're compute intensive or have some states, things like this?
Okay. So yeah, so the question around where the Pulsar functions run, execute in the computing stage. So there's 3 different runtime options. One is you can run it in thread mode, so it can run inside the broker itself. And this is good for edge deployments because the broker and compute are separated. So if you wanted to put something out on the edge, you could do that. Another option is process mode. So you can have a dedicated set of servers called function workers that run them as individual processes, and you can stand those up and run. But our preferred method for production is Kubernetes pods. So you can say, this is my Kubernetes runtime, and they get spun up inside that infrastructure, and they get run as pods. And so if they die or crash, they get restarted automatically as well. And then you can use function mesh, which is an open source tool that we committed to the CNCF, which allows you to link multiple functions together, so the output of one becomes the input of another, and so on and so forth, and you deploy them as a single unit so they can get started and stopped automatically as well. So it's a Kubernetes pod is how they get run. Man, I sure hope this works this time. It's going to be so much cooler if it runs. So I had dashboards and everything. I spent a lot of time on it. Oh, but still creating the tables now. So the data should be coming in. Any other questions? Okay, here we go. So now we're going through the phase. We're creating the ticker table. That's the one I need. Let's see if this one's in here. Oh, you better work. There's something going on. What is with this demo? What is with this? Oh, it dropped. It disconnected. Thanks. This one, you just verify. That should be okay. I'll try the Hilton Honors. It was working. That's what I ran up in my hotel room before I came down. Should work. Not sure why it didn't. This is truly annoying, but. I'm gonna restart it, see if it works. Just that feed. Man, nothing's working on this thing. Real-time summit. Password is real-time. All right, we'll start this one more time. Do this. Now it's got to have multiple things. Sorry, I'm keeping everybody from their lunch. I apologize for this. I think I have a connection now that I did the ping. It's tracing it out. Just takes a minute to stop everything, and then we'll restart it. All right, 1. And part of the process is long because I have to pause when I create the Pinot tables because they don't like it when you create a table defined with as a Pulsar connector and the table doesn't exist yet because it's sort of dependent upon the data coming in from the WebSocket, right? So I've intentionally put a 20-second pause in some of these table creation process just to be overly cautious to make sure the tables get created successfully. And the Pulsar broker has to start up a little bit first before you can create the function. So I put a 15-second pause in there for that as well. So that's what we're doing in the. So you can see we're just sort of intentionally taking a few pauses there to make sure that the tables get created. You have to initialize superset, import dashboards, and everything should work. So that's kind of what the script does. So we started the data feed. Now we're creating the content-based routing function. Okay, now we're going to create the ticker stats function using the Python method as we mentioned. They should all be up and running. Created successfully, so that's creating. Gotta just hope it connects to the network now. Now we're gonna create Pinot, stand up all its good stuff one more time. Controller, broker, superset, everything. My shot clock is expired, I'm sorry. I appreciate everybody staying and suffering through these technical difficulties with me. I really appreciate it. It is a cool demo at the end, I swear, if you have a network connection. Okay, there we go. So now we're creating the tables one at a time. So we created the Coinbase ticker one, was successfully added. We wait 5 seconds, we go ahead and create the next one. Ticker stats were created. Now let's see if we can go in here. Yay, there's data. Should have had this ready before, Dave. But you can see this is real live data. This is coming out. You know, you can check your portfolio. Wow, Bitcoin's down a bit today. It was 63,000 yesterday. Not that I trade it, but I've looked at this data set for a week. But all this data is there, right? So now we can look at all this information is there. We got some stats. So you computed some more interesting values with that. Some information is there, so it's all sitting there. It's all running in real time. And now, just to prove that superset is working and we're going to win this hackathon. Yeah, I'll change it later. Volatility isn't there yet. It's a later stat. So you can see I'm breaking down. This is the total trade volume of all those different coins that I'm interested in. This is your trade. This is a trade volume by pure raw value, number of coins. This is the number by dollar values, highs and lows. And one more thing, I know, ready to ask questions. Get out of here. Just to show you that I did one for an individual coin, so you can see this is the price in real time. I'm tracking the EM exponential weighted moving averages. These are your different metrics, variances, standard deviations, everything like that. So all that data is available. It tracks in real time, and you can see it right there. And so I appreciate everybody's patience. That's all I have. Any other questions? Thank you very much. Thank you.